talking about a right triangle. I'm just talking about triangles in general. Remember from your geometry days that in order for a triangle to exist, the two smallest sides must be larger than the largest sides when you add them up, when you sum them up. So that's just a general rule. If this does not happen, you do not have a triangle. So if your two smaller sides, if you add them up and it's not greater than your largest side, then you don't have a triangle. Simple? All right. Do you guys remember Pythagorean theorem? Okay. So here's the deal. If a squared plus b squared equals c squared, you have on your hands a right triangle. Everyone knows how that looks like. It looks like that. A, B, and C. If a squared plus b squared is greater than c squared, take a guess. There's only 3 options total, and I already used one of them. It's not an obtuse, it's an acute triangle. And that one would look like, they're all acute. They're all cute. That was lame, I know. I'll stop. All right. And if you have a squared plus b squared is less than c squared, meaning the long side is way larger when you square it than a squared plus b squared, then you have an obtuse triangle. Yeah, where that means there's one angle that's obtuse because you can't have 2 angles that are obtuse. So that means you have something like this. See? Where that is C, that's A, and that's B. There's your obtuse angle. Does that make sense? Now, a lot of your textbooks, when you get to the university, depending on what textbook you get, I just flipped to 3 random textbooks, and then I went to even Google. This was a long time ago, not today. And I saw that they kept doing it like this. They go c squared greater than a squared plus b squared, and then they call that obtuse. I don't know, maybe it's easier to remember that way because, c squared greater than a squared plus b squared. I don't know. What do you guys think? Do you guys think this is easier to remember than writing it like that? I mean, I don't know. It doesn't really matter. To each their own. Okay, so here we go. Ready? So in the beginning, by the way, I don't want to take credit for this first handout. This first page, notice that it's all nice and orderly. Everything's in boxes with bullets. When I make my notes, I do not type all those little notes. So I don't remember who to give credit for the first page. I want to say it's, man, I can't remember her name. I can't take credit for it. Someone else made the first page. No, not here. It's from. Yeah, it's that lady. In the bottom, it said well, no. See, this one doesn't have it. But there was a copyright down here, and it had like a name. But I didn't crop it out. Whoever sent it to me cropped it out. I think they wanted to take credit for it. I didn't crop it out. I don't crop anything out. All right. Here we go. Or, maybe by accident. I don't know. All right. Here we go, guys. Here we go. I'm going to go ahead and first find out if I have a triangle. The 2 smaller sides are 3 and 7. It just so happens that on all these, they put the 2 smaller ones on the left. They don't have to do that. 3, 7, and 9. Those are the sides. Does 7 plus 3 greater than 9? It is. So I have a triangle. So then I do this. I write 3 squared plus 7 squared, and then I put some space, and I write 9 squared. And I'm going to see what this is. So 3 squared is 9. 7 squared is 49. And 9 squared is 81. 49 plus 9 is 58. So 58 and 81. What's greater, 81 or 58? 81. Because the c squared is greater than a squared plus b squared, what type of triangle do I have? Yes, obtuse. Sorry. I don't know why it took me a while there. Yeah, it's an obtuse. I didn't have much sleep, so, I'm going to blame it on that. Are we okay with that? Okay, now let's look at number 2. I have a 20, a 21, and 29. So 20 squared plus 21 squared, and I'll put the 29 squared on the side. I do not know what those numbers are, so now I need my calculator. So let me take my calculator out. Come on, buddy, hurry up. I should have done this earlier, sorry. I'm going to do the 29 squared first. So 29 squared. Oh, look, I have a whole bunch of junk in there. 29 squared is 841. So I type 841 down here. And then I go 20 squared plus 21 squared. So I'm going to go 20 squared plus 21 squared. 841. So what type of triangle do I have? It's a right triangle. So this is a right. All right, look at the next one. 4 plus 11, does that greater than 16? No. Nope. 4 plus 11 is not greater than 16. So what I have? Not a triangle. Let's go to the next one. One last one. I have a feeling this one's going to be an acute 17 squared, and 22 squared. So, yeah. 17 squared. Oh, I put 27. 17 squared plus 17 squared. 578. And 22 squared, I have a feeling, is a much smaller number. I mean, not much smaller, yeah. 484. So, what's bigger? That one. So, what type of triangle do I have here? Acute. So, there it is. We did all three situations. Cool or not cool? Cool. 5, 6, 7, 8. If you want to do those, that's fine. But let's not do them now because we're trying to, be fast. Okay. So a quick, real fast overview of geometry. Really fast. When you draw a triangle, by the way, you can only use SOHCAHTOA for right triangles. When you draw a triangle, label your vertices with capital letters. And then angle A creates little a. Angle B creates little b. And angle C creates little c. Does that make sense to you guys? Okay. There it is. That's all you got to know. I'm going to make a grid. Well, that's not all you got to know, but I'm going to make a grid and I'm going to draw that same triangle but in this grid here. I'm going to call that A. I'm going to call this, I guess I'll call it the same, A, B, and C. So because that's A, this is little a. Because this B, this is going to be little b from here, from this distance to that distance. I guess I should not do the same color there. And I don't know why I didn't connect it. That's B. So then this distance is little b. And then this distance here is little c. All right, guys, focus, focus. Are we okay so far? This is at the origin. So this coordinate here is 0, 0. Point B is at some coordinate, some x coordinate, some y coordinate. And point C, I don't know the magnitude, like I don't know the number, but I know that the x value better be what? No, not 0. The y value is 0. It's positive what? What letter can I use? Does that make sense? If you don't understand that, please let me know because that's that segment, right? From the 0 all the way to that vertex C is just segment B, whatever that number is. Does that make sense? Are we clear? All right. Now remember, guys, all of you know the Pythagorean theorem. So you're going to see it like this. This is only for right triangles. Only for right. Everyone knows that a squared plus b squared equals c squared, where c is the longest side. Always, right? All right. Law of cosines looks very similar to Pythagorean theorem. Very similar. I'm going to focus on, I don't want to use that color. Let's use this red. I'm going to focus on this dark red triangle. Just for a little bit. You guys see that? So this distance here that I'm doing in a special red, that is just some x value. Because it tells me right there, x. This vertical displacement, or you can also call it your height, that's just going to be some y value. Does that make sense? Okay, now do you remember the distance formula, which is related to Pythagorean theorem? The distance formula that you guys remember from your geometry and algebra 1 days is just the change in x squared plus the change in y squared. And the square root of that will give you the distance. That's just a side note, right? So you don't remember that, guys? You probably saw it like this. x1 minus x2 squared plus y1 minus y2 squared. And then probably d squared, maybe like that. Is all that familiar to you guys or no? Okay. That's just how to find a remember, distance and Pythagorean theorem, they're related, guys. This technically is Pythagorean theorem in disguise if you don't see it, but hopefully you see it. All right. So look what I'm going to do. I'm focusing on that red one. And if I focus on angle A, because I'm focusing on that red one, I can say this. I'm going to use SOHCAHTOA. SOHCAHTOA. And I'm going to write sine of angle A is equal to, it tells me opposite. Opposite is y over hypotenuse. What's the hypotenuse of that triangle in red? Well, yeah, C. Perfect. Write that. And I'm going to write cosine of angle A is equal to adjacent, which is just some x, divided by the hypotenuse, which again is C. Are we okay so far? From that, I can tell you that if I multiply both sides by C, I can get this, that y equals C sine A. And if I do the same thing with cosine, I can get x by itself, which is going to be C cosine A. Are we still okay? All right. Now I'm going to try to go as slow as I can, guys. I'm going to try to find the distance A, and I'm going to utilize the distance formula. So what am I doing right now? I'm just going to find the length of that segment A. So so here it is. I'm going to use the distance formula. I'm going to use this guy. So if I'm trying to find the distance A, I'm going to write A squared equals, open parenthesis, I'm finding the change in x. So what I'm doing right now, guys, is I'm getting this distance in black. Do you guys see that? So I know the distance from the origin all the way to point C is just B. So B minus, and then if I subtract this triangle in red, or at least the x-axis part, if I subtract that x, I'll know that I'll get that black segment squared. Does that make sense to you guys? Perfect. Plus, open parenthesis. Now, the top point way over here at vertex B, that's just a y value. And the bottom point way down here, that's just a 0. So there's my vertical displacement. So there's my horizontal displacement, vertical displacement. Are we okay so far? So check it out, guys. All we're doing is arithmetic. I have an expression here for x that I can substitute right there. And I have an expression here for y that I can substitute right there in order to get this expression, my a squared, in terms of just my letters a, b, and C. Cool or not cool? So here we go. A squared equals, parenthesis, b minus c cosine A, close it squared, plus parenthesis, C sine A, close it squared. I am done with pre-cal, or geometry if you want to call it that, or trig. I'm now just doing arithmetic. A squared equals B times B. B squared minus B times C cosine A is BC cosine A, but how many of those am I going to have? So 2BC cosine A plus, because negative times a negative, C cosine A times C cosine A is, C cosine A all squared. I'm going to write it like this, C squared cosine squared A. Plus, and then if I just square this guy, it's going to be C squared sine squared A. Am I okay? All right, I'm going to group these two here. And then I'm going to factor out a C squared. So here's what I have. A squared equals B squared minus 2BC cosine A plus, here's my factored out C squared, cosine squared A plus sine squared A. What's cosine squared plus sine squared? What's cosine squared? Yeah, it's a Valentine's formula, guys. Valentine's just passed. Cosine squared plus sine squared is 1. So here we go. Let's put it in alphabetical order. A squared equals B squared plus C squared, which looks a lot like Pythagorean theorem, minus 2BC cosine A. Oops. Cosine. Oh, man. How do I delete that? Hold on, guys. All right, let me get my mouse. Delete. All right, there we go. And there it is. That is the law of cosines. If we wanted to solve for b squared, relax, it's really easy. Let's use context clues. If I wanted to solve for b squared instead, it would be like this. A squared plus c squared minus 2ac cosine of b. That's also law of cosines. Chop, what if you wanted to find for c squared? Okay, that's fine. C squared equals a squared plus b squared. I guess this is the one that looks most like Pythagorean theorem. A squared plus b squared equals c squared minus 2ab cosine c. All three of them are law of cosines. Chop, when am I ever going to use law of cosines? Well, hopefully you used it in physics when you were doing two-dimensional motion and they asked you for the displacement between 2 points. I guess you could always use just Pythagorean theorem. But if you have vectors like, that look like this and they want the resultant vector, and maybe you got a triangle, it's very useful. Chop, when do I use the law of cosines? Use to find segment length or angle of triangle. Of course, you need two sides and an angle at least, right, to do any calculations. Cool or not cool? Don't worry, we're going to show you how to use it. Look at all this beautiful math, guys. A lot of this is like art. Do you ever show this to your parents? No? Like, look how beautiful it looks. It looks awesome, no? I think it looks awesome, guys. If you're wondering okay, Chop, what was the point of all that we just did? Guys, I want to show you where the law of cosines comes from. I could very easily be that teacher that says, here's the law of cosines, use it. Do you want me to be that type of teacher that just gives you formulas and you don't know where they come from, but we're just using it? I mean, I know maybe some of you are like, just give me the formula. I don't care where it comes from. But I want you guys to see that these formulas come from somewhere. They just didn't make themselves up. Like, oh, just use the formula. It comes from somewhere. Look, we just derived it. You derived this formula on your own. Well, as a class. And look, we did it. Cool, no? Okay, here's how you use it. So for those of you that just show me how to use it. Here's how you use it, guys. Example 1. Does everyone have your calculator? In triangle PMF, I'm going to put not to scale because my triangles are never to scale. Measure angle M is 127, P is 15.78, and F is 8.54. Find the measure of the third side M. Okay, so they don't tell you it's a right triangle. They just tell you it's a triangle. So I'm going to draw a triangle. I'm going to draw an obtuse triangle because of that. So here's my obtuse triangle. So here's angle M, here's P, and here's F, my vertices. So little m is right here. I don't know what that is. That's what they want me to find. This is little p, so 15.78 feet. And this is little f, so 8.54 feet. Are we okay so far? Here's angle M. Angle M is 127 degrees. Does anyone have questions? All right, look what they want me to find. They want me to find the third side M, so they want me to find this, question mark. I got everything I need. According to my theorem, law of cosines, if I want M, so M squared is equal to P squared plus F squared minus 2PF cosine of M. See? If I want little m, it's the big M that's inside the cosine. Yay or nay? Big M's this guy, the 127. Yeah, the cosine of M is cosine of that angle. Are we okay, guys? So if I want M, all I got to do is take square root. Square root, where's my P? 15.78, so 15.78, square that dude, plus, where's my F? 8.54, 8.54, square that dude, minus 2 times 15.78 times 8.54. All this is still as a square root. Cosine of 127 degrees. Look, you can just do it in one sitting. I'm going to take my calculator. Don't worry, I'll get back to it, guys. And I'm gonna clear this. I'm going to go square root. And I already forgot, short-term memory. What was it, guys? 15 point what? 78, close it, squared. Plus, what was the other one? 8.54 squared minus 2 times times, and then I hit up what cosine of what angle? 147? 127. I couldn't remember, miss. Oh, should I put 124? Man, I'm so bad. 127. I don't think I saw any mistakes. No, there's oh yeah, nope. Yeah, there's mistakes. Where's my mistake? Because I don't remember it being that. All right, let me see. Oh yeah, there's a square right there. Right there, there's a square. Okay, 15.78, 8.54 cosine 127. Enter. Did you guys get that? Okay, so then we're good. 22.003. 22.003 feet. If they say nearest foot, that's 22 foot. And that's it. You're just going to be doing that over and over again. Well, that's not it. We got one more, but yay or nay. All right, so look at example 2. This one wants the largest angle. So for that to exist, it better give you all three sides, because that's the only way you're going to be able to figure out the largest angle. So it says triangle XYZ. Okay, so I'm going to put NTS, not to scale. X, Y, Z. Oh, it's definitely not to scale. Big X gives me little x, which this guy's 3 down here. Y gives me little y, so this one's 7. And Z gives me little z, so this one's 9. They got to give you all three sides, side, side, side. Which one is the largest angle? X, Y, or Z? It's not to scale, so don't look at this picture and say, oh, it's the X or it's a Y. X, Y. No, I'm saying you're no, not, oh, sorry, it's not it. Oops. Ah, man. Yeah, I heard someone say it. What is it? Z, Y. Yeah, it's angle Z. And I'm sorry, I should next time I'll choose better letters than X, Y, and Z. It's angle Z because Z creates the 9. Do you guys see that? So it's not X, it's not Y. Angle X is the smallest one. Cool or not cool? So because I want to find angle Z, the 9 is what's going to go on the outside first, because I'm going to put cosine Z. Here's what okay, Charles, what are you talking about? Law of cosines, here it is. I'm going to write it. Little z squared equals x squared plus y squared minus 2xy cosine of capital Z. That's what I'm doing, guys. So if I want to find angle Z, I got to put little z on the outside. So here we go. 9 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine Z. Are we still okay? Now remember, Chop, what are we doing? I don't know. I'm lost. I'm 100% lost. You're trying to find the angle Z, so you're trying to get cosine Z by itself. Does that make sense? All right, what's 9 squared? So 81 equals 3 squared, 7 squared, minus 2 times 3 is 6, 6 times 7. 42. Did I hear you guys say 42? Okay. All right. So now I'm going to move. I guess let's do it slow. 81 equals 49 plus 9 is 58 minus 42 cosine Z. I'm going to move the 58 to the other side. So minus 58 minus 58. 81 minus 58. 58, 68, 78, 23. 23. I have to go in sections. Equals negative 42 cosine Z. Remember what we're trying to do, guys. We're trying to get cosine Z by itself. So all I got to do is divide by what? Negative 42. So here's what I have. Cosine Z equals negative 23 over 42. If you want to put the negative with the 42, that's fine. We are so close. How do I get Z by itself? Inverse. Inverse cosine or arc cosine. Doesn't matter which one. Now, someone in first period asked, Chav, how come you didn't put the plus minus like you've been doing all first semester? That was a good question. I don't put the plus minus in front of the inverse cosine in this case because do I care about negative angles for a triangle? No, so that's why I don't put the plus minus. Whatever the calculator spits out is my answer. Does that make sense? So I take my calculator, make sure you're in degree mode, mine is, and I'm going to push second arc cosine, put a negative, and I already forgot, short-term memory, what was it? 23 over 42. 123. Yeah, it's an obtuse. 123.2. So obviously my picture is not even anywhere close to scale. Z equals 123 point. I already forgot what it was. 2 degrees. There it is. How do you feel? We probably could have been better. I probably could have been better. Check it out, guys. 7 squared, 3 squared, add them up, and then I think it's 58 is bigger than 81. So yeah, 58 is bigger than 81. That would have been an obtuse. I'm doing this stuff over here. See? Wait a minute. That doesn't make any sense. I just said 58. Why did I say 58 is greater than 81? 81 is greater than 50. Okay, we're in this one. 81 is greater than 58, so it's an obtuse. Guys, you guys got to stop me when I say wrong things. I say wrong things all the time. Especially when I'm tired. Okay. How do we feel? I'm going to delete that on my YouTube. I'm going to edit my video. Good thing I can edit it. All right. Yeah, I didn't get much sleep, guys. But I'm sure you guys didn't get much sleep either, right? I'm going on, I think maybe I got 3 hours. Maybe, but I think I got less. It's because I chose Whataburger. Whataburger life. All right, here we go. No, I did. It was midnight, and I'm like, do I want to sleep or do I want to eat? And I chose to drive to Whataburger. All right, example 3, last one. Suppose the lengths of the sides in example 2 have been 3, 7, and 11. What would the measure of angle Z be in the case? All right, look at the 3, 7, and 11 carefully. What do you notice? Look at it carefully. It's not a triangle. You have this. You have something that's an 11 there. 3 and 7. Look, if this were to be like a little pivot, or I don't know what you call it, a swivel or whatever, it would just fall down. It would just hit the floor. It wouldn't close to make a triangle. So if I try to do law of cosines with this, I better not get an answer. And you don't. Watch. If you were to try to do law of cosines, 11 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine of z. Like doing the same thing that we just did. 121 equals 9 plus 49 minus 2 times 3 is 6. 6 times 7 is 42. Cosine z. 121 equals 58 minus 42 cosine z. Minus 58 minus 58. 58, 68, 78, 88, 98, 108, 118. So 63 equals negative 42 cosine z. If you see me make a mistake, let me know. Divide. So cosine z equals a negative 63 over 42. Check it out, guys. If I try to type this into the calculator, it's going to tell me, I hope, no, it will. It's going to tell me error. It's going to say, what are you trying to do, buddy? So, sorry, I don't know why I said buddy that way. Second, arc cosine, negative, what was it again? 63 over 42. Look, check it out. If I try to type this in, it's going to say, whoa, hold on, what are you trying to do? Because it's not possible. Because you don't have a triangle. It knows, the calculator is smart. It knows, how does it know that? Because this ratio on the inside better be between negative 1 and 1. It's a number between negative 1 and 1. So if it's outside that range, it's going to give you an error. Does that make sense, guys? All right, I think we're good. Did you understand all that? All right, then I think all you got to do is just practice. So let's go ahead and log in and see if you guys can take care of it. Good job. Good job.